Hi guys, let's take a look at the root of a complex number. Here I have a complex number, 8 take 6i, and we're going to take the root of that number. Now, to start that off, let's bear in mind that the root of 8 take 6i is a complex number itself, so we can say, oh, that's z, the complex number. And we also know that z is often written as a plus bi, which seems to be a good idea here as well. Now to solve this, we're going to square both sides. So we get rid of the root. 8 take 6i is going to be z squared, which consequently is going to be a plus bi squared. Now I'm going to concentrate on the 8 take 6i and the a plus bi squared, and if I find a and b, then I will have my z. So 8 take 6i is a squared plus 2abi, and then bi squared, so that's b squared I squared, so let's take b squared, because I squared is -1. Now we look at the real parts and the imaginary parts again, because they need to be equal. On the left hand side there is a complex number, on the right hand side there's a complex number. The real parts of those need to be equal, and the imaginary parts. So the real parts, on the right hand side, a squared take b squared, on the left hand side is 8. Imaginary parts, 2ab on the right hand side and -6 on the left. Turn them around, but it doesn't really matter. So now what I can do is I can say from this one, b is -6 divided by 2a, so that's going to be -3 over a. And I can use that result and plug it in there in the first equation, because this is two equations, two unknowns again. So we get a squared take -3 over a squared equals 8. Working that out, it says a squared take 9 over a squared is 8. Now that's hard to solve, but I'm going to move the 8 to the left hand side. Everything's going to the left hand side. I'm going to make the right hand side 0, and I'm going to multiply everything by a squared to get rid of the bottom here of a squared. So a squared becomes a to the power. The 8 goes to the other side where it's -8. It gets multiplied by a squared. And this -9 over a squared gets multiplied by a squared, so that's -9. So now this equation, this is the same equation, but it looks more like a quadratic now. A quadratic in a squared. I can actually factorize this, and I can say, oh, that's a squared take 9 times a squared plus 1 equals 0. Just factorizing that equation. Use the null factor law, so a squared take 9 is 0, or a squared plus 1 is 0. This one leads to a being positive or -3, and that one leads to a squared being a -1, and in this case a is my complex number z. Z is a plus bi, so a needs to really be a real number. It can't be a complex number anymore. So this does not give me any solutions. So here I cannot take the root of that -1 because I defined a as a real number. B is a real number as well, by the way. Together with the I, it is the imaginary part of the complex number. So a is going to be plus or take 3. That result I can use and plug back in there, and I can find b. So b, oh wait a minute, I have to choose a first. If a is 3, a positive 3, then b is negative 3 over 3 is negative 1. If a is negative 3, then b is negative 3 over negative 3, which is 1. So z is either 3 take I, or z is negative 3 plus I. There we go. Now that's taking the root of a number. So the final conclusion, the root of 8 take 6I is either 3 take I, or it is negative 3 plus I. As you would expect, taking the root, you get two options. Now the other thing that we can do with complex numbers is that divide them. And yep, got my preparation here. Now there's something funny, or not, I'm not sure it's funny, but there's something nice about division of complex numbers. Let's first divide a plus bi over c plus di. So that's basically dividing a complex number over another complex number, z1 over z2. The trick that you can do is to get rid of the imaginary part in the denominator. To do that, we multiply with the conjugate number, conjugate complex. The bottom here will turn out to be c squared plus d squared. Squared take cdi plus cdi, and this is going to be negative d squared I squared, which is a positive d squared. The top, I could FOIL this, but I'm not going to. I'm going to keep it keep it in terms of z. So this one is z1, and this one is the conjugate of z2. The bottom here, if you look closely, that looks like the modulus of a number. It is the modulus of z. But we forgot to basically take the root of it. So it's not the modulus of z, it's the modulus of z squared. So now we have a little rule that makes division of complex numbers a bit quicker. We have the rule z1 over z2 is z1 multiplied by the conjugate of z2 over the modulus of z2 squared. So there's a handy thing to remember. To solve this particular question here, let's start with cross multiplying. Z plus 1 times 2i take 1 equals z take 5i multiplied by 3 plus I. And I'm going to expand that. So I get 2zi take z plus 2 equals 3z plus zi take 15i take 5i squared. So that's a plus 5. Then I'm going to bring all the terms with z to the left hand side and all the terms without z to the right hand side. That's a smarter move because we want to isolate z. So I have 2zi take z, and then I get a negative 3z, and I get a negative zi. And on the right hand side I have negative 15i plus 5. And I also have a negative 2i plus 1. Now I can bring a z as a factor, take out z as a factor, and inside the brackets there's going to be a real part and an imaginary part. these ones, this is negative 4z, so there's going to be a negative 4. And for the imaginary ones, there's a negative I and a positive 2i. So that's a negative 4 plus I. On the right hand side, I have 5 and 1 is 6. And I have negative 15 and negative 2 is negative 17. So the only thing that I need to do now is divide. Z is going to be 6 take 17i over negative 4 plus I. And I know how to do that because of this. 6 take 17i multiplied by negative 4 take I, the conjugate, over negative 4 squared, 16, plus 1 squared, that makes it 17. And I'm going to work this out, and it will end up to be negative 24, take 6i, plus 68i, and then it's going to be a negative 17. So the answer is negative 24 take 17, that's negative 41. Negative 6i plus 68i is positive 62i, all over 17. That's the answer to the problem.